Okay, Assalamualaikum and hi everyone. So I would like to explain the solution for this group work 1 question. So we have here a 200 kilogram spool and rest against the wall and the floor if the coefficient of static friction is equal to 0.3 and the mu k is 0.2. The wall is smooth. Determine the friction force developed at B. So means that the question asks you to calculate the friction force at B. Friction force at B. So we don't know either the spool is in equilibrium or in motion, since they give you both mu S and mu K. And then they also give you the P value, which is 800 Newton. Okay, so first thing first, of course you need to draw the FBD. Okay, we have of course the weight of the spool with 200 kg, which is equals to 1962, and then with the distance 0.1 we have 800 Newton here, 0.1 meter, and we also have the radius of the spool with 0.4 meter. And then at point A, since the wall is smooth, so there is no friction at point A, but still we have the normal force at A, while at point B we have the normal force at B, and of course we have the friction. So since the spool is having a force of a vertical force of 800 Newton, the spool will rotate clockwise, so our friction force at B is directed to the right. Friction force at B. Okay, so I did not label Fs since we don't know either the spool is in static friction or in kinetic friction. Okay, so I just label the FB. So F stand for friction force. Okay, next we have already our FBD. So as usual, we are going to apply the static equilibrium equation for rigid body, starting with the moment equation. Summation of moment about point B, since point B having the most number of unknown, which is 2 unknown, compared to point A having 1 unknown. Alright, so from point B we have NA that is rotate counterclockwise, so NA is positive times the radius of it. So this is the distance. We have 0.4 meter. And then W, the W here, there is no moment. There is no moment at W, since the W is applied directly to point B, right? So there is no moment. And then we have another one, 800 Newton, that rotate clockwise. So negative 800 times 0.1, right? 0.1. So NA we get 800 times 0.1 divided by 0.4. We get 200 Newton. Okay, next one we have summation of Fy equals to 0. Okay, we are going to calculate the normal force at B. Okay, normal force at B, positive upward. And B upward minus W1962 plus 800. So NB, we got 1962 minus 800, 1162 Newton. Okay, but the question here asking you to calculate, to determine the friction force at B. So we have FB to the right positive, minus NA, we have 200 Newton. So we got friction force at B equals to 200 Newton. So this is the answer. But since the question give you the mu S equals to 0.3 and mu K is equals 0.2, we need to justify either the spool is in equilibrium or in impending motion or either in kinetic position. Okay, kinetic. Alright, so the friction force is at B, FSB. So we are going to use the static coefficient. 0.3 times NB, we have 1162. So we get 0.3 times 1162, 348.6 Newton. So this is the situation here. F maximum, right, equals to mu S N. So this is also equals to F maximum. Okay. And then how about FK, kinetic friction? So we have 0.2 times 1162. 0.2 times 1162 equals to 232.4 Newton. Okay, since our friction force here is 200 Newton, where it is less than Fs and Sb, alright, 200 Newton also less than Fk. So therefore the spool is in equilibrium. Okay, so the F max here is 348.6. Kinetic here about 232.4 Newton. So our force, the friction force here is 200 Newton. So this region is in static, or we call it as equilibrium, right? So that's why we got to justify here that the spool is in equilibrium, since the friction force is less than F maximum and Fk. That's it. Thank you.